Unit 5A, Lesson 2. In this lesson, we're going to use some of the theorems we discussed to find missing angles and missing arc lengths created within circles. In the first example, we're going to work with inscribed and central angles. So we have an angle ACB and an angle ADB. Both of these angles are intercepting arc AB. If we know the measure of arc AB is equal to 60 degrees, we want to find the measures of those two angles. So first, if we're trying to find the measure of angle ACB, that is a central angle. So the central angle is going to be congruent to the arc it intercepts. So that angle will be 60 degrees as well. Now if we're trying to find the measure of angle ADB, this is an inscribed angle because the vertex lies on the circle itself. So the measure of this angle is going to be half of the arc it intercepts. So half of 60 degrees is going to be 30 degrees. So the central angle is congruent to the arc it intercepts. The inscribed angle is half of the measure of the arc it intercepts. In the next example, we're going to again be working with inscribed angles. This relates to theorem 10.9. So we have angle PSQ intercepting arc PQ, and then we have angle PRQ also intercepting this arc PQ. If we know the measure of arc PQ is 40 degrees, then we should be able to find the values of these inscribed angles. So first, if we're looking for the measure of angle PSQ, this is an inscribed angle, so its measure is going to be half of the arc it intercepts. So half of 40 degrees is going to be 20 degrees. Now if we're looking for the measure of angle PRQ, that again is going to be an inscribed angle, so its measure is half of the arc it intercepts. Half of 40 is going to be 20 degrees. So that's what theorem 10.9 tells us. If we have two inscribed angles intercepting the same arc, then they are going to be congruent measures. In this next example, we're going to be dealing with adjacent arcs. So we know arc DC is 30 degrees, arc AD is 100 degrees, and arc AB is 120 degrees. The first thing we want to find is the value of this missing arc, which is BC. So we need to recall that a complete circle is 360 degrees. So if we take 360 degrees minus 30 minus 100 and minus 120 degrees, that's going to leave us with what remains. So if we take 360 minus 100 minus 120 minus 30, we're left with 110 degrees. So the measure of arc BC is going to be 110 degrees. Now we want to find the measures of arc ABC and the measure of arc AC. First, if we want to find the measure of arc ABC, if we have three letters referring to the arc, that implies it's a major arc, meaning it's going to be greater than 120 or 180 degrees. So arc ABC consists of arc AB and arc BC, so we simply have to add those two arcs together. AB is 120 degrees, arc BC we just found is 110 degrees, so if we add those together, arc ABC is going to be 230 degrees. Similar idea if we want to find the measure of arc AC, that consists of arc AD and arc DC. So if we add those two arcs together, 100 plus 30, the measure of arc AC is going to be 130 degrees. In this next example, we're going to use theorem 10.10. So we have a triangle that is inscribed within this circle. We can see that we have one of the legs or one of the sides of the triangle is the diameter of the circle. So according to this theorem, if this side of the triangle is the diameter, then this must be a right triangle. So we know the measure of angle C is 90 degrees. We were given that the measure of angle A is 43 degrees. So now if we want to find this missing angle, the measure of angle B, we know the two acute angles are going to be complementary. So the measure of angle A plus the measure of angle B must be 90 degrees. So if we take 90 minus 43, the measure of angle B is going to be 47 degrees. In this example, we're going to use theorem 10.11. So we have a quadrilateral ABCD that is inscribed within this circle. If we have a quadrilateral that is inscribed within this circle, then we know opposite angles must be supplementary. So we know the measure of angle A and C must be supplementary, and the measures of angle D plus B must be supplementary. And what we want to do in this example is solve for x and y. So we want to find the values of these variables. So first we can take 3y plus 2y and set those equal to 180 degrees. 3y plus 2y is 5y equal to 180 degrees. And if we would divide by 5, you get y equals 36. We could use a similar idea to solve for the value of x. If we take 8x plus 10x, we know that must be equal to 180 degrees. So 8x plus 10x, we get 18x equal to 180. Now we would take 180 divided by 18, and we get a value of x is equal to 10. So that's how we can solve for those variables. If we wanted to find the measure of each angle, for instance, if we wanted to find the actual value for the measure of angle A, we would take the y value we found, which is 36, plug that back in for y, so we would take 36 times 3 to get a value of 108 degrees for the measure of angle A, and then we could use a similar idea to find the measures of angles B, C, and D. The next example is going to relate to theorem 1012. So we have a chord AB, and then we have a tangent line, which is line B. It's a tangent line because it intersects at the point of tangency, which is point B. We know the measure of arc ACB is 220 degrees. The first thing we want to find is the measure of arc AB. Again, if we know a circle is 360 degrees and we subtract the measure we know, 360 degrees minus 220, arc AB must be 140 degrees. Now we're going to use theorem 1012, which gives us an equation we can use to find the measure of these two angles that are created by the chord and the tangent line. First, if we want to find the measure of angle 1, that is going to be equal to 1/2 times the measure of this arc it intercepts. So if we know the measure of arc AB is 140 degrees, multiply that by 1/2, you get the measure of angle 1 to be 70 degrees. Same idea to find the measure of angle 2. We know the measure of the arc it intercepts is 220 degrees. If we multiply that by 1/2, we get a result of 110 degrees. We can quickly check to see if these angles are reasonable, because if we look at our tangent line, line B, if this is a straight line formed by two adjacent angles, this must add up to 180 degrees. Because this forms a linear pair, if we add angle 1 and angle 2, two adjacent angles that form a line, that's a linear pair. They must be supplementary. Angle 1 plus angle 2, if we take 70 plus 110 degrees, we get 180 degrees. In this next example, we're going to use theorem 1013, which deals with two chords intersecting inside the circle, and then we can find the values of the angles that are created. In this problem, we know the measure of arc RS is 35 degrees, and the measure of arc QP is 75 degrees. So first, if we want to find the measure of angle 1, this theorem tells us we have to use the two arcs that angle 1 intercepts, which would be arc RS and arc QP. All we have to do is add those two arcs together and multiply the result by 1/2. So if we add 35 degrees plus 75 degrees, you get 110 degrees. Multiply that result by 1/2. The measure of angle 1 is going to be 55 degrees. Now, we don't even have to use that theorem to find the measures of the other angles, because if I'm looking for the measure of angle 2, if we look, angle 1 and angle 2 form a straight line, so they're a linear pair because they're adjacent angles, meaning if I add angle 1 and angle 2 together, that result, that sum, has to be 180 degrees. So if I take 180 degrees minus 55 degrees, we're left with 125 degrees. Now if I'm looking for the value of angle 3, angle 1 and angle 3 are vertical angles, so they must be congruent. So the measure of angle 3 must be 55 degrees. And a similar idea, or the same idea, to find the measure of angle 4. Angle 2 and angle 4 are vertical angles, so they're going to be congruent. So the measure of angle 4 must be 125 degrees. In the last example, we're going to use theorem 1014, which deals with finding the angle, or a circumscribed angle. It's an angle that's formed on the outside of a circle, whether we have two secant lines, two tangent lines, or a secant and a tangent line. The same idea is going to apply. So we know the measure of arc AB is 55 degrees. The measure of arc CD is 15 degrees. Using that information, we want to find the measure of angle DEC. So what this theorem tells us is, if we find the difference between arc AB and DC, and then multiply that result by 1/2, that's going to give us this angle. So if we take 55 minus 15, we get 40, and then we have to multiply that result by 1/2. So we get the measure of angle DEC is going to be 20 degrees. So we can use this theorem. The same idea applies if this was two tangent lines that were intersecting outside the circle, or if we had one secant line and a tangent line intersecting outside the circle. This same theorem is going to apply. We find the difference between the two arcs that are intercepted, and then multiply that result by 1/2.